A very warm good afternoon to all of you. I am Sakshi, welcoming you all on behalf of Solar Quarter and First View Group to Jinko's High Energy Density Bifacial Module and Energy Storage Solutions webinar. I take the pleasure to thank our speaker for investing his precious time to join the event, and a very special thanks to our partner Jinko Solar for their immense support to organize this event. I would now request my team to play the promotional video. Thank you so much, team, for playing that video. It's exhilarating to know that one of the most well known and cutting edge solar technology firms in the world is Jinko Solar. With a focus on the research and development of integrated photovoltaic products and integrated clean energy solution, this company spans the key links in the solar industrial chain. As it works to develop a new energy ecosystem, Jinko Solar consistently broadens the diverse application scenarios for PV technology, including solar integration into buildings, PV hydrogen production, energy storage, and other areas. Join us for this technical and knowledge sharing webinar. And may I now introduce Mr. Sai Charan, who is the Technical Director of South Asia at Jinko Solar, to give the presentation for his company. Over to you, Mr. Charan.
Thanks, Sakshi. Let me just share my screen. Hope you all can see my screen.
Yes, it's visible.
Great. Very good afternoon, one and all. Thanks for joining us for this particular session. And the kind of trends, what exactly are happening specific to PV and ESS are more relevant to energy security in this particular current era. So starting with that particular preamble, so I just would like to give you a kind of brief introduction about Jinko Solar. So it's more like, as you all very well know, like Jinko Solar is the vertically integrated manufacturer, starting from ingot to wafer to cell, and then cell to module. Out of all these particular segments, right from the day of our conception, we have delivered more than 150 gigawatt capacity across the globe. And specific to Indian market, we have crossed beyond 8.5 gigawatt capacity. And altogether, if we just try to see the kind of market share what we have, at least within India, it's beyond 30% kind of thing, and across the globe, average it's standing beyond 15% kind of thing. And on top of it, if we just try to see the kind of manufacturing capabilities what we hold, for 2022 we were standing at around like 40-45 gigawatt capacity, and by the end of this year we are going to touch around like 90 gigawatt capacity. And this all is happening just because of the kind of quality consciousness what we generally try to hold, and the kind of R&D team capabilities that we have when compared with any other core competitors within this particular segment. More importantly, how exactly this is happening, like if we just try to look at the kind of path breaking technologies which we always try to get in onto our platter, which generally happens with the high power density kind of technology, not just limiting ourselves on the power density part, but also spreading our horizons more importantly on the segments of energy security, also more specifically on the aspects of energy density as well. So this all can happen within these kind of new innovations, which can happen within the P type kind of technology, or even within TopCon N type kind of technology as well. So specifically, if we just try to talk about P type kind of technologies, as on date we already have crossed beyond 23% kind of efficiency on P type kind of technologies, and on N type, a laboratory efficiency cell has already crossed beyond 26.4% kind of efficiency. And the kind of cell what we are using within the mass production is standing at around like 24% to 25.4% kind of efficiency. So altogether, some kind of optimizations are being happening on the TopCon kind of production itself. Like initially, it started with during the days of Q2 2022, we were providing the N type as TopCon plain vanilla kind of technology, which used to come with temperature coefficient of 0.3% per degree C rise in temperature, and with degradation factors of less than 1% for the first year, and year-on-year degradations as 0.4%. The same technology we tried in optimizing as a kind of TopCon 2.0, we named that, with a selective emitter as a kind of optimization on the base material itself. That's how we have seen that the temperature coefficient of the same material has been reduced to minus 0.29% per degree C rise in temperature. So these all are kind of technology optimizations which are happening to increase the power density. And similarly, we always try to do some kind of optimization on the energy density as well, in order to increase energy density, as what we are trying to provide with tiling ribbon kind of technology options, which is what our Tiger series modules, which generally comes with 470 watt peak, generally holds that kind of specific element, which generally comes with high energy density kind of aspect. And that comes with these kind of tiling ribbon kind of technology more predominantly. If you just try to look at any kind of N-type kind of technology or a TopCon, we are trying to provide with 16 bus bar, where the power class is going to stand at around like 580. And within P-type, if you just try to see, monoperk technology is already there, with which is coming with 10 bus bar kind of technology with 540 watt peak, but that is only high power density. The moment if you are trying to go for high energy density, probably you need to go with these kind of technology options, where you usually can see that cell to cell overlapping is happening with this kind of tiling ribbon. So this is a kind of tiling ribbon which we try to use. This is a bit circular in shape, wherein which it will have the option and optimized configured value specific to corners of the cell, which is anyway not going to generate anything. But the moment when this particular tiling ribbon is going to be placed, its overlap of this particular unutilized area is happening. Just because of that particular reason, you can see energy density is going to be increased. So that's a kind of technology optimization which we tried in doing with Tiger series kind of module, which is why any kind of 470 watt peak modules which are coming with monofacial or bifacial variant with transparent backsheet kind of options are good to go kind of solution. And that too, these are not standard typical 5 bus bar kind of technology options, which is what is there with normal 400 watt peak kind of solutions. This is more importantly, this comes with this comes with 163.75 as a kind of wafer size instead of 158.75. So which is why you usually can see that power density is also more for this particular technology, and also energy density is also more. And this all is happening just because of this particular increased bus bar mechanism. So that way it will have much more energy increment on the energy density part. So that's how it generally happens. And in normal case, if you just try to see, people always try to go with a kind of flat ribbon mechanism. But with flat ribbon kind of mechanism, probably the light redirecting film is not going to have 180-degree or 360-degree kind of light absorption coefficients. The moment if you just try to go with these kind of circular ribbons, probably you will have better reutilization of this particular light, whatever is going to happen, whether that can be with low irradiance or even with high potential irradiance factors as well. So that way, we easily can see that this particular 9 busbar technology module, which generally comes with 163.75 wafer size modules of tiling ribbon technology, are having better power density and better energy density when compared with the conventional 5 busbar kind of technology modules. And on top of it, if you just try to see, since these particular technology modules are coming with 9 busbar kind of thing, the kind of the mechanical strength, more importantly, is going to be stiff, and strength is also going to be increased with this kind of tiling ribbon technology modules when compared with normal 5 busbar or 3 busbar kind of modules. So altogether, if people are trying to go with these kind of 9 busbar kind of technologies with tiling ribbon kind of modules, probably you'll have better energy density. Also, there are 10 busbar technology products which are more predominantly called as Tiger Pro series, which generally comes with circular ribbon but not the tiling ribbon, where the power density is going to be more, which means for 2278 by 1134 kind of dimension module, you easily can generate 550 watt peak from that particular dimension module. But the only thing is that it is having only high power density. But when we try to compare the same with tiling ribbon kind of technology, so it's going to have high energy density with these kind of 470 watt peak modules. So in short, if we just try to see, for tiling ribbon kind of technology products, we have our Tiger series in both monofacial and bifacial, which can address the needs of high energy density kind of products. But if you are looking at only high power density kind of products, probably our monoperk technology, which generally comes with 10 bus bar, 550, 555 kind of power class, which is coming in both monofacial and bifacial, can cater your needs. On top of it, if you still want to go with high power density and high energy density at a higher power class value, definitely our Tiger Neo series, which is our TopCon series, is always available. So that can be even provided with 72 cell kind of option with the same dimension of 2278 by 1134. So that is depending on the capacity availability, probably that can cater your needs. But it is more like we have a capacity constraint on that particular product because it's high power and high energy density. But to cater your needs immediately, probably this particular technology product of Tiger series module within these kind of bifacial modules can easily suffice your requirements on this particular technology. And as I was trying to explain you that, since when compared with the normal 5 busbar technology versus a 9 busbar kind of technology, you can see that the reduction of micro cracks is going to happen. So since number of bus bars are going to be increased, mechanical strength in between these particular ribbons is going to be increased. So that way, it will have better mechanical strength when compared with normal, 5 bus bar kind of technology products. So that way, it is more reliable when compared with normal flat ribbon kind of technologies. You can see here that this is a kind of tiling ribbon, which generally appears in circular in shape. The moment this particular ribbon is going to be placed in between cell to cell, so this is getting pressed over here. Since this is
Mr.
getting pressed
Shannon,
over,
so sorry to interrupt you, but if you could just put the presentation on slideshow mode. We're just looking at the first slide right now.
oh,
If you can click the slideshow option
yeah,
on your.
I have clicked in the slideshow option. You're not you're not viewing the same.
No, the slideshow is not visible.
Let me just share it once again. Can you see my screen now?
Yes, now it's visible.
Okay.
Very well. Thank you.
I'm so sorry. It's more like I was trying to explain you all these particular slides. More importantly, specific to the shipment and the capacities what we have delivered and what exactly is the capacity that we can manufacture within the year, and more predominantly the kind of efficiencies what we hold. And on top of it, it's not just limiting only to Tiger Neo series, but even on the P-type kind of products, we try to provide Tiger Pro series up to 550, 555 kind of power class within P-type kind of technology, and with N-type, it can go even up to 690, 590 kind of watt peak. And within this particular Tiger series kind of module, going with tiling ribbon kind of technology, where you easily can see that cell to cell overlap is going to happen. So this particular tiling ribbon easily eliminates the cell gap, which obviously will increase power density, and also more importantly, since low light utilization is going to happen in a much better way, so this is going to have high energy density. So that's how we easily can determine that within P type kind of technology, high power density is Tiger Pro series, high energy density is Tiger series. So that way Tiger series module generally comes with 470 watt peak, which is coming in both monofacial and bifacial variants, will have this particular option of high energy density. And this is how a normal square, normal flat ribbon versus circular ribbon, which generally is being classified. And specific to circular ribbon, where you will have 360-degree utilization of reutilization of light can happen, whereas for normal flat ribbon, it is not possible. And just because of this particular 5 bus bar versus 9 bus bar comparison, the mechanical strength of this particular 9 bus bar is going to be more, which can reduce the micro cracks when compared with normal 5 bus bar kind of technology. And this is how the pressing aspect happens between cell to cell, because this is how the ribbon looks like, which is circular in shape. And the moment cell to cell overlap is going to happen, it will press this particular portion over here, where in which it will create some kind of tension. That's how it's going to be more stiff in nature, and is going to have better intensity of absorption when compared with normal flat ribbon kind of technology. So altogether, if we just try to compare monofacial versus bifacial, definitely bifacial is predominantly taking major market share when compared with monofacial kind of modules. And reliability wise, if we just try to see for these particular bifacial modules, going with a combination of PoE plus EVA or EPE plus EVA kind of combination is making much more sense, which easily can see the kind of radiation absorption coefficients are going to stand as close as PVF materials. So that way it is more like third generation K films also can consider the kind of requirements, what exactly is required for these kind of encapsulants. So that way it is going to have these particular transparent backsheets, more importantly, because it's more predominantly, people always try to think that bifacial means it always comes with a dual glass kind of module. But the most important factor is that it is not just only the reliability factor, but also there are certain other factors, more importantly, on the fronts of anti-UV or humidity, or even more specific to abrasive kind of zones, where sand resistance kind of modules and high humid zones, all these particular aspects to be withstandable. And for this particular thing, if we just try to go for PQP kind of standard testing on these kind of transparent backsheet modules, definitely if that is going to pass through, so there won't be any kind of concern or issue specific to these kind of bifacial modules which are coming with transparent backsheet kind of options. And which is the reason why Jinko we provide with both kinds of options. It's more importantly for Tiger series, we provide with transparent backsheet kind of modules, which generally comes with 470 watt peak, and with a normal uh, P-type kind of products always comes with transparent backsheet, and with N-type kind of technology products, more importantly, Tiger Neo series of 580 watt peak in bifacial, probably that can be provided with dual glass kind of options. But the only challenge is that if we just try to compare dual glass option of bifacial versus transparent backsheet of bifacial, there is a kind of myth that people think that the kind of reliabilityness specific to transparent backsheet is not so eminent when compared with dual glass kind of options, which is not the fact, because we even tried in testing these particular aspects for both of our products. The only thing is that if you are trying to go for any kind of high wind zones or even a kind of high humid zones, uh, probably this kind of bifacial dual glass may provide some kind of better mechanical strength when compared to transparent backsheet, which again generally comes as a kind of normal conventional module. But predominantly it always try to go for these kind of PQP kind of testing, or IEC 2016 or latest standard of 2021 kind of standard testing is going to suffice the requirements. And more importantly, if we are trying to go with this kind of backsheet, we always try to ensure that it will minimum withstand to the kind of conditions specific to UV regulation, so that it should absorb those particular coefficients when compared with normal back sheets, which generally comes as a kind of white back sheet. So that way, if the encapsulant, which is coming in transparent encapsulant, which generally comes with PoE or EPE kind of combination, plus PoE plus EVA or EPE plus EVA kind of combination, if these particular aspects can be catered, can look at the reliabilityness of the product, definitely you will not be having any kind of issue. So that's how we generally try to consider. Let me just explain you this particular slide more in detail. In normal case, assume that if there is a kind of 4 to 3 kilowatt hours of insolation or irradiation is available on the surface of your module. But what exactly is going to reach down is only 10%, which means only 342 kilowatt hours is going to reach the ground surface. Depending on the albedo percentage, the reflection sensitivities are going to vary. The moment if you are trying to have a kind of Tedlar or PVF kind of materials, or even third generation K films, which has the capability to absorb 2800 kilowatt hours kind of sensitivity, if those particular backsheets are being used here, more specific to these kind of transparent backsheet materials, you easily can generate better values of you easily can obtain better bifaciality factors when compared with normal bifacial modules. So that way we easily can see that the kind of availability of this particular irradiation versus the amount of irradiation which is exactly touching the rear side of the module is going to vary. So that's how we easily can see that only 10% is getting hitting on the rear side. Out of that particular 10%, depending on the uh, uh, depending on the albedo percentage and bifaciality factor of that particular technology, this value will vary. Which means assume that if ISC of your module is going to stand at 14 amps or 13 amps, so maximum, as since radiation is directly proportional to your ISC or IMP, so only 1.3 to 1.5 amps on a kind of fixed tilt system can be expected on the rear side surface of the module. Altogether, for a bifacial module, as an instantaneous current value, you can see that for a 14 amp module, you can see that maximum of 15 to 16 amps is a kind of amperage which can be expected, which is why there is no need of change in the design considerations specific to bifacial module uses. Of course, if you are trying to go with any kind of tracker kind of mechanism, this probably can be increased up to 10% more, which means instead of 16 amperes, you may go up to maximum of 18 amps. And that too, our JBs, whatever is provided with these particular diodes are capable to withstand up to 20 amps and with a maximum series fuse rating of 30 amps. So that way you'll not have any kind of challenge more specific to these kind of bifacial modules which are coming with transparent backsheet kind of options. And on the reliability factor, more specifically on the fronts of tensile strength or elongation at break, since these all are happening on AR based within the line. So these are even trying to portray better values when compared with normal conventional kind of modules. So that way, tensile strength is also at a better value when compared with any other factors, whether that can be with damp heat or the thermal cycle or humidity freeze or UV, any particular factor specific to these particular tensile strength options. It's already showcasing better values of reliabilityness when compared to normal dual glass kind of modules or even with any kind of conventional solar PV modules, which generally comes as a kind of monofacial module. Not just limiting only to those particular factors of high tensile strength, also on the factors of transmittance factor and peel strength, with the encapsulant materials, which generally should portray beyond 50 Newton per centimeter. So on all these particular conditions, for all these particular reliability test conditions, it is always portraying beyond those particular values, which is why we easily can say that the reliability factor specific to these particular bifacial modules with transparent backsheet can withstand to all kinds of temperature zones. It's only that on the specific requirement, people try to go with these kind of bifacial dual glass kind of modules. Since we are open to all kinds of options, we provide in both materials, but more predominantly for these kind of tiger specific materials, which generally comes with high energy density kind of technology products, we try to provide with these kind of transparent backsheet materials. So that's how even on the fronts of any other reliability factor, whether that can be with thermal cycle of 3 times or damp heat of 3 times IEC or humidity freeze or PID of 192, all these particular factors, if you just try to look at the values, the kind of degradation values is always less than the recommended value of IEC. So that way it is having better values when compared with normal conventional modules, and it is good to go with a similar kind of mechanism of transparent backsheet for Tiger series kind of modules. And we did a kind of typical analysis in just comparing bifacial dual glass modules versus transparent backsheet. And the interesting analysis what has came out is that, of course, transparent backsheet has got the mechanism of evaporation, which is why the operating temperatures of these particular bifacial modules will be lesser when compared with dual glass, because glass becomes opaque in nature at higher temperatures. So that's how you easily can see that there won't be any kind of air inflow or outflow for bifacial dual glass modules. But whereas for transparent backsheet, it acts like a kind of breathe in and breathe out kind of mechanism, which is the reason why, just due to change in this particular temperature, operational temperature of the module, we can see better energy density is going to happen more with these kind of transparent backsheet kind of modules. And we tried in testing with different kinds of options like fixed tilt on a kind of sand surface, or even with any kind of conventional solar PV modules. We can see better energy density is going to happen more with these kind of transparent backsheet kind of modules. And we tried in testing with different kinds of options like fixed tilt on a kind of sand surface, or even with any kind of which has got the albedo of 30%. And similarly with the tracker option, where we had seen 1.62% of extra energy gain, there's a kind of simple uh, comparison between dual glass modules and transparent backsheet kind of modules. But still, depending on the need and requirement, we try to provide that. And if end client is more predominantly looking at dual glass kind of modules, yes, we provide it for our normal case modules specific to 550 kind of watt peak modules, or even with our N type modules, we try to provide with dual glass. But for these kind of transparent backsheet modules, we try to provide with these kind of high energy density technologies. Like for Tiger series, we try to provide with transparent backsheet modules. And this is how the kind of energy density variation has happened throughout the year. There's one of the case study which is on a sand fixed tilt kind of mechanism, and even the same on a tracker kind of solution, and similarly on a kind of fixed tilt kind of system with RCC as a kind of the ground texture, which is having more than 40% of albedo, where we easily could see that the kind of gain which has happened is beyond 9% when compared with normal bifacial kind of modules. And these all has been proved just because of one simple reason. Because when we try to compare with normal bifacial module, dual glass module versus transparent backsheet module, it always has got the lower operating temperature. Just because of this particular lower operating temperature, you will have better values of energy yield when compared with normal dual glass kind of modules. So that's how, which is the reason why we try to provide our Tiger series module, which generally comes with tiling ribbon, is always being provided as a kind of high energy density because of this particular reason. Because it will have low operating temperature when compared with normal dual glass kind of modules. The same can be even attributed even for our Tiger Neo series or Tiger Pro series. But still, since the market is inclined more towards high power density with those particular technology products, which is why we are trying to provide those particular products with dual glass kind of modules. And that too, this particular transparent backsheet are a bit expensive when compared with dual glass kind of options. So which is the reason why we try to provide it as a kind of customized solution when compared with normal dual glass kind of modules. Not just limiting ourselves only to these particular PV kind of solutions, but yes, even on the energy storage segment as well, starting from 1 kilowatt hour till 3.4 megawatt hours, we just try to provide different kinds of solutions. On the name of sun tank, we provide it as a kind of RESS solution, which is residential energy storage product, which is there up to 50 units of energy requirement. And similarly for C&I storage system, which is more predominantly for the DG application, where for any kind of specific requirement up to 1 megawatt hour, with a simple 20 feet kind of container, we can provide these kind of solutions. And we try to call that particular product as Sun Giga. And similarly for utility scale, where RTC tenders or hybrid tenders or any other standalone tenders which are trying to get in place with these particular options of 3.44 megawatt hour as a kind of simple containerized solution in a kind of 20 feet container, probably this particular solution is highly feasible. And altogether, which we try to call these particular products as sun tank for residential segment, where you easily can see that this can be stackable on a low voltage side, and even on high voltage three phase 4 wire kind of options also can be made within this particular sun tank kind of solution. And similarly for C&I kind of application, where we try to call this particular product as Sun Giga, where we have our intelligent mechanism specific to liquid cooling, which is not forced air cooling mechanism, where our auxiliary consumption with this particular technology products, what we have done is entirely less. Like you easily can see that 20% less auxiliary consumption is going to happen. And you easily can see the 2.5 degrees C as a kind of variation in temperature when compared with other conventional products. And that is even applied even for our Sun Terra solutions as well. So that way we try to provide both Sun Terra and Sun Giga solution more predominantly for megawatt hour kind of applications. And specific to C&I kind of market, which generally comes in a kind of cabinet, where we try to provide this particular cabinet solutions up to 1 megawatt hour. And it can be provided in both DC and AC kind of interlinking mechanism options. So that way we easily can see that these kind of battery solutions, which are generally coming in containerized solutions, which we try to provide in different ampere hour options. Because even we have plans of going for cell level manufacturing as well. In very short time, you also are going to hear from us on that particular segment. And more predominantly for sun tank kind of solutions, we try to go with 50 ampere cell, which is 3.2 volts, 50 ampere hour. And similarly for Sun Giga kind of solutions, we try to go with 3.2 volts, 100 ampere hour kind of solutions. And similarly for these kind of Sun Terra kind of solutions, we try to go with 3.2 volts, 280 ampere hour kind of solutions. Or in very short span, we even will be touching 320 ampere hour as well. So that way you usually can see that the kind of energy density what exactly we are trying to provide with these kind of container options, containerized solutions is going to be a bit higher and highly feasible and highly reliable when compared with other conventional battery containerized solutions. Why exactly it is going to be highly reliable? The reason is that we are trying to maintain a kind of five layer protection on the compliance requirements, more specific to fire and safety part, which is why the kind of liquid cooling mechanism what we are exactly trying to provide, it's going to start with simple pack level onwards. It's not just that on a single complete container kind of solution, but it's going to start with complete pack level onwards. Even for the entire pack, it's going to be there, and the same liquid cooling mechanism is going to be flow through even for the entire rack, and then even for the entire solution. So that way, we easily can see that the LCOS, which is the levelized cost of storage, is going to be down by 20% just because of this particular reason. And that's how we have increased our energy density when compared with our competitors. So that's how we easily can see that auxiliary power consumption is going to be reduced, and where in which we easily can increase the LTE part also. More specifically, the RTE also can be increased, and on the DC side we easily can touch around like 92% to 93%. And similarly, if we just try to look for the AC side, probably by the PCS design, probably that can touch around like 84% to 85% kind of values. So with this, I end the presentation and would like to take your questions.
Much for that insightful presentation, uh, Mr. Charan. I'll be just screening some comments and you can answer those.
Any specific instructions on the design of MMS for bifacial modules? Yes, probably we generally try to provide our manual. You easily can even use these particular bifacial modules uh, on any kind of normal monofacial module mounting structures as well. But the only thing is that if you're trying to go with these kind of bifacial modules, it's always recommended to go with minimum 0.5 meter to 1.2 meter kind of spacing from the ground level, so that you can get better uh, the intensity of these particular ray side radiations can be absorbed in a better way. But if you don't have that kind of space availability, so even you can even go with 100 mm to 300 mm is also fine, but your energy density is going to be reduced in that particular case. I could see one more question. Is there any desert condition panels and 540 watt peak and above? Yeah, Mr. Raghavendra. So more specifically on the desert conditions, we don't have any specific or special panel for that. What we always try to look at is for any kind of desert kind of conditions, it has to withstand to high humid zone, high thermal cycle, and high abrasion activity. If these particular three factors are getting satisfied, whether that can be with bifacial jewel glass or even with transparent backsheet. And more predominantly for 540 watt peak, it happens with bifacial jewel glass. If we are trying to go with 470 watt peak, probably with these kind of third generation K films, which are highly acceptable and susceptible to these kind of conditions, where high humid temperatures, high humid zones, and high temperatures also can withstand with high abrasive environment, probably that even can be considered. So that way you'll not have any kind of challenge specific to these kind of desert conditions. And we have even got 1.2 gigawatt kind of capacity at a single location, more specifically with this kind of product of Tiger series kind of module. And that way you usually can see that whether that can be with Tiger series or Tiger Pro series, we don't recommend any specific or different module, but yes, the existing module can suffice your requirement. Mr. Sumant Kot, has these tests conducted in any location in India? Yeah, more importantly, if we just try to look at these particular products, the kind of requirements, specifically the compliance requirements, if we just try to see, they come up with normal BIS recommendation, which is there with as per IEC 2005 standard. Probably that may not suffice the requirement. But still, if you just try to look at IEC 2016 standard, or even if you just try to go for thresher condition, which is having a kind of two times of IEC kind of cycle, probably that suffices the requirement. So probably what you easily can do this particular thing is that if any of these particular products are running in the market, running in field for more than 2 years, or even for 1 year, one full cycle, probably you can very well consider these particular products. Apart from that, if you still want to conduct these particular tests, probably you can even go for a kind of third party testing, which is highly possible. And but the only concern is that it's highly time consuming activity. But yes, if we just try to look at markets like US, they try to go for PQP testing. And PQP testing process itself generally takes not less than 6 months. If you have that particular luxury of spending 6 months to 9 months kind of time, probably you can very well go for that during PSI, which means during pre-shipment inspection, you very well can do that. Or else the other option, what people always try to look at is, if any of these particular products are having those particular test reports, at least internally, people try to go with that particular confidence. The reason is that at the end of the day, on any single module, if you find any kind of degradation concern, definitely it is going to fall under product warranty and performance warranty. So that way, you easily can consider that as a kind of highly confident and highly safe condition for you. Hope I answered your concern. Somondra Halda, please mention the temperature, rise or heat permissible limit in the surface of the installation, when which permissible as per OEM without any effect, generation or warranty. Please also mention anything above permissible limit which can be allowed with its. Okay, Mr. Somendra from Sun Green Power. It's more like the temperature. If we just try to talk about the temperature, the modules wherever we are trying to test as per the testing conditions of IEC 61215, it's going to be tested in between minus 40 degree to plus 85 degrees C. And at any point of time, you consider any kind of module under any kind of temperature or ambient condition zone, wherein which the maximum temperature of the module is not going to cross beyond that. Probably ambient temperature of our regions may go up to maximum of 55 degrees C. If the ambient temperature is going to stand at 55, probably the maximum cell temperature or the operating temperature of the module is going to stand at plus 20, which means plus 75 to 80 is a kind of maximum temperature. And also we need to see if there is happening any kind of extreme high temperature. Then we need to see within the module, if you are observing two different temperatures with a delta variation of 20 degrees C, then that can be a challenge of creating hotspot. Otherwise, if the entire module is standing at the same temperature with no variation within the module, it no need to be worried for that particular reason. May I know the fire class for the Tiger series module? Tiger series module, we generally try to provide class C, not only for Tiger series, but for any series of our module. We always try to go with class C. Mr. Kannan, if you say the air is breathed in and out, is there any moisture ingress? Okay, so specific to these kind of bifacial modules, which generally comes with transparent backsheet, or even if you just try to look at for any kind of monofacial modules also, which are being operated in the floating kind of applications more predominantly, where we have a factor called WTR, water transmission rate. If this particular value is being limited to 2 grams per square meter to 3 grams per square meter, probably it will not have this particular challenge, because it's that particular value is completely allowable to have any kind of, in not to have any kind of drastic effect on the module. So that way we try to maintain this particular WTR value in between 2 to 3 grams per square meter per day. So that way it is highly safe and it can be accepted. For monocrystalline bifacial panels, is there any part shadow or full shadow permissible? If yes, what is the shadow allowance on daily or on yearly or monthly basis without hampering the output of the modules and their agreed degradation warranty? See, more importantly, for bifacial modules or even for any kind of module, front side shading is completely not allowable. If it is a kind of dynamic shade, probably you will not have any kind of challenge. But assume that if it is a static shade, which is happening on the front side of the module, it will impact on the hotspot. And for the rear side of the module, it is not at all a challenge. The reason is that rear side of the module always absorbs diffused irradiation and the reflected irradiation. So which means all the time, the rear side of the module always works in shade. And the kind of temperature, what exactly is being shared between front side of the cell and the back side of the cell is the same. So that way there won't be any kind of change in temperature from front to rear side of these particular cells. So that's how you'll not have any kind of variation in the output wise or even on the degradation parameter wise, because rear side of the module is completely getting operated on the shaded zone itself. And when it comes for the degradation or warranty wise, it will remain same like normal conventional modules. More specifically for these particular bifacial modules, we try to provide 12-year as a kind of product warranty and 30-year as a kind of performance warranty. When compared with monofacial, probably they will be standing at only 25-year as a kind of performance warranty. But for these kind of bifacial modules, it's going to be more. What is the effect of shadow? Right. It shadow has to be looked in two different ways. Whether this is dynamic shadow or it's a static shadow. If it is a kind of static shadow which is happening on the front side surface of the module, it will impact on the not only on the generation but also on the product performance and on the life of the module by creating these kind of hotspots. Also, if you are not trying to maintain the module, assume that there are certain word droppings on the surface of the module, and if it is not clean for more than 2 months, it will have an impact of hotspot creation. So that's how the effect is going to be created. Assume that if it is only a kind of dynamic shade which is happening only in the non-peak hours, like starting from 3 p.m. onwards, just due to land constraint, if people tried in reducing the pitch between table to table, probably that will not have major impact. System load 160 kilowatt, require battery size and panels. So if you're trying to go with 160 kilowatt as your system load, it completely depends. Like you can very well connect to our sales team. We can provide you different options within this, whether you need 1 hour backup or 2 hours backup. Probably our Sun Giga solution may suffice your requirement. More specifically for 4 hours kind of requirement, probably we can provide you with 1.6 or 1 megawatt hour kind of solution also. So it completely depends on what exactly is required for you, or 0.5 megawatt hour is even sufficient. So we can provide you with our existing ESS solution. So probably you have to get connect with our sales team. So they'll get in touch with you. Mr. Santu Badra. Is painting the concrete surface with any white paint help in achieving more generation? Absolutely. If you are trying to have a kind of RCC surface, and if you are trying to maintain minimum spacing of 0.8 meter to 1.2 meter, it definitely will help you in getting better albedo factor by just going with white paint. The moment if you increase this particular albedo factor, your generation gain is also going to be more. And that even can happen depending on the percentage of albedo. If your albedo percentage is going to stand at 80%, you even can get gain of around like 20% of energy gain also, which has happened in Peru kind of locations. Ajay Shukla, how much additional efficiency one can expect after painting the reflective paint? That completely depends. Sorry. If you're trying to go with a kind of reflective paint, uh, assuming that if your bifaciality factor remains same and albedo factor is going to be maintained at 100%, which is what you easily can see that it's not efficiency gain, it's more of like your energy density is going to be increased up to 20% if you are trying to go with a kind of pure white with 100% albedo factor kind of thing. Sorry. If you use these products with dual access tracker, IMP value will increase by 40 to 45%. Will busbar JB cable will withstand? Of course. If you're trying to go with a kind of dual access tracker, probably if your IMP value is going to increase up to 40-45%, assuming under worst case scenario, with this kind of 570 watt peak module, which is coming with transparent backsheet, or 470 watt peak module, which is coming with transparent backsheet kind of module, assuming that if that particular IMP value of that particular module on the front side of the module is going to stand at 12 amps, this particular 12 amps may become with 45% more, which means 12 can become 18 amps maximum. I'm considering the 50% as a kind of gain. And the kind of JB which we are trying to design is going to withstand up to 20%. And similarly, the kind of series fuse rating, what exactly we are trying to provide, is going to withstand up to 30 amps. And this is at any point of time, this is not going to have any kind of effect, even going with this kind of dual access tracker. And the kind of energy gain happens, whatever is going to happen for you, is going to happen on the entire day basis. Whereas if you just try to look at these particular values on instantaneous power basis, definitely this will still lie less than this particular value what you have mentioned. So that way you'll not have any kind of challenge. It easily can withstand. Krishna Gupta, could you throw some light on what would happen if the bifacial module with transparent backsheet be installed in tin shed? Would there be any bifacial gain, if any, because the clearance will be less than 50 mm? Of course, what would be the temperature? Loss at clearance will be very minimum. Okay. See, if you're trying to go with any kind of tin shed, probably we always try to mention our clients also to maintain minimum 100 mm spacing for the sake of free flow of air. If you are trying to maintain less than 50 mm, definitely you'll have your effect on increased temperature, which will increase your operating temperature of the module, but it will not have any kind of instantaneous gain or effective, the kind of effectiveness what generally comes with bifacial modules, that may not happen on these kind of tin sheds. But yes, even on floating kind of applications where this similar kind of spacing has been maintained on water kind of applications, where the water resistance, just because the light sensitivity is very less over there, because reflective sensitivity is nullified over there on water surfaces. Even there also we had noticed that 2 to 3% kind of extra energy gain with bifacial kind of modules, which is the reason why even for floating applications also people are trying to go with these kind of bifacial modules. And similarly to your case also, if you're trying to maintain 50 mm instead of zero 0.5 meter, if you're trying to go with 50 mm, instead of getting 5% or 7% of extra energy gain, you may be end up with 0.5% to 1% kind of energy gain only. And as per the temperature effect, anyway, these all are capable to withstand up to 85 degrees C as a kind of maximum operating temperature. So that way it will not have any kind of effect on the entire performance of the module, because these all are withstanding to TC cycles of 100, 200, and 300. Could you please provide a list of inverters compatible with BESS? So this completely depends. It's more like because the kind of solution what we are proposing is not just a simple component. We are trying to provide this as a kind of energy solution. So which means it's going to comprise of its own energy storage solution. Means like it's a combination of battery bank along with BMS, and even our PCS is also going to be provided along with that, with the EMS, energy management system. So altogether, battery bank plus battery management system plus your power conditioning system plus energy management system. All these particular three components together becomes BESS solution. So that way, compatibility wise, if you ask us, yes, we are compatible with most of these particular inverters who are providing these particular PCU solutions. How to address micro cracks when handling on high rise rooftops, especially handled manually while installing? So yes, this is a kind of common challenge which is generally there. What we always try to suggest is that if you are trying to hold the module in a proper way as per the manual whatever we are trying to provide, you will not have these kind of concerns. But yes, if you are trying to go with people who are not even semi skilled in just handling these particular high length modules, you will have this particular issue. But it's always recommended that you please go with, as per, if you try to follow as per our manual, probably you will not have these particular issues. Abdul Azim from Geetam. Hi, good evening everyone, this is Abdul Azim. Oh, could we get presentation slides material? Yeah, we'll try to provide you the PDF. You can get that. Sorry. Any tips while installation to garner maximum generation on these panels? Yes, it's more like if you are trying to follow our installation manual and the kind of spacing if you are trying to maintain between panel to panel, and minimum ground clearance if you are trying to maintain, and if you try to maintain good ground texture in increasing the albedo factor from the ground, definitely you will have better generation when compared with normal conventional monofacial modules. Sorry. What factors should be considered when designing a solar PV system using bifacial modules, such as spacing, tilt angle, and ground cover? Sushil Kumar Singh. Yeah, it is more predominantly if you're trying to design any kind of solar PV system with these kind of bifacial modules. What really matters is definitely if you're trying to go for utility scale, all these particular things matter. And if you're going to install this particular thing on a rooftop with a limited space, probably as per that particular specific condition, you have to do this. And yes, all these particular factors really matters in increasing your specific energy yield. Is there any training for installation bifacial installing bifacial module? Yeah, it's more of like you have to follow our manual. So probably that provides good insights. And also we have released one of the white paper on our bifacial module. If you can try and go through that, probably all your concerns and questions can be addressed. That's more specific to installation. Is there any possibility of hotspots on the rear side? No, it's more like, since we are using the same cell, so there is no possibility of having different hotspot on the rear side. If any hotspot is going to happen, it will happen on the front side as well. It's not that only on rear side it can happen. Do you suggest any tool to design bifacial modules? Yes, it's more like you can even design these particular solutions or systems on normal PV Syst or even PV Sol or any other many other algorithm softwares are available in the market. You can try with that.
I think that's that's the questions we had for today. Would you like to give any closing remarks, Mr. Charan?
Yeah, I'm really very sorry to all of you because of the technical glitch which has happened initially, where I could not share my slides, but eventually it ended in a very good manner. So thanks for your time and thanks for your patience. Uh, on any kind of requirements, you definitely can reach out to us, where our sales team is available to cater all your needs and requirements. So once again, I thank Solar Quarter team and Sakshi for this wonderful session.
Thank you so much for that insightful presentation, of course, and a very special thanks to you uh, for this wonderful questions that you answered. A big shout out to our attendees for extending their time and support to the event. And of course, not forgetting to thank our partner Jinko Solar, who helped organize this event. And we promise to be back with more exciting sessions soon. Thank you so much, everyone.
Thank you. Thanks, everyone.